Okay, so when we are given actually some data sets, sometimes the data might be wrong, right? It could be some error due to human error. There could be like some cases which might not be applicable to the data set. And so what we're going to do is identify these outliers. So an outlier is a value which seems to be outside the trend of the data, i.e. it's an anomaly. And there's many different ways of identifying an outlier. The most common way is this one here. If it's larger than Q3, the upper quartile, plus some K value times the interquartile range. Remember the interquartile range was the difference between Q3 and Q1, right? If it's larger than this value, then we note it as an outlier. Or if it's smaller than Q1 being the lower quartile minus K times the interquartile range. And K is just a scalar value. Normally, in most cases, it's 1.5, okay? But it all depends upon the question. So the question will tell you what to use to identify as an outlier. As I said, this is just the most common way of identifying an outlier, but in different questions, they might say, oh, it's a different value or a different range, which you identify as the outlier. So it just all depends upon the question. Right, let's look at this one here. So some data is collected, Q1 is 46, Q3 is 68. A value greater than Q3 plus 1.5, so K is 1.5, times the interquartile range, or smaller than Q1 minus 1.5 times the interquartile range, is defined as an outlier. Work out whether the following are outliers. So let's work out the range at which it becomes an outlier. So it's going to be Q3 plus 1.5 times Q3 minus Q1. So Q3 is 68 plus 1.5 times 68 minus Q1 is 46, which will give us 101. So if it's bigger than 101, it's going to be an outlier. To find the lower value, it's Q1 minus 1.5 times the interquartile range. So Q1 is 46 minus 1.5 times 68 minus 46. And so the lower value would be 13. Okay, so if it's larger than 101, it's an outlier. If it's less than 13, it's an outlier. As you can see, these 7 and 105 would be outliers, therefore. As I said, the definition of an outlier is not always the example we looked at before. There are certain other limits for an outlier. So in this case here, we have the masses of an Arctic fox, which are found, and the mean mass was 6.1, and the variance was 4.2. An outlier is an observation which lies plus or minus 2 standard deviations from the mean. So as you can see, it's a slightly different definition of an outlier. So let's find a lower value. So it's 2 standard deviations from the mean. So it's going to be the mean minus 2 times sigma. Or it's going to be the mean plus 2 times sigma. This would define the outlier range. So the mean is 6.1 minus 2 times the standard deviation. Remember the variance is 4.2, so the standard deviation is going to be the root of 4.2. And the other upper one will be 6.1 plus 2 times 4.2, like this. So if it's bigger than this value here or less than this value here, it's going to be an outlier. So this is going to be less than 2.0, and if it's going to be bigger than 10.2. Any of these values would represent an outlier. As you can see, the only outlier here will be this 11.5 kilogram one. So you can say that this mass, the mass of this fox is outside the trend, so it could be an error in the measurements. B, what are the smallest and largest masses that an Arctic fox can be without being an outlier? Well, the smallest obviously is this 2, because anything less than 2 would be an outlier, and the largest would be 10.2, because anything larger than 10.2 would also become an outlier.